Okay, I waited for 5 minutes. I don't know why the network cut off. Yeah, I waited. Guess it worked. And we're back. Okay. Um, with that being said, I was doing this right. Um, I was doing this, and even if I take that out, nothing happened. Numpy is not needed also. So, so what is it is correct? Right. Oh, small. Two sample J test. Okay. In this test, we have provided two normally distributed and independent populations, and we have drawn samples at random from both populations. Here we consider U1 and U2 to be population mean and X1 and X2 to be the observed sample mean. Here our null hypothesis could be like this: mu1 minus mu2 equals to 0, and alternative hypothesis mu1 minus mu2 is not equal to 0, and formula for calculating the z test score is x mean of x1 minus mean of x2 minus population mean uh, 1 minus population mean 2 by root under sigma 1 square plus sigma 2 square divided by n1 and okay, where sigma and sigma 2 are the standard deviation and n1 and n2 are the sample size of population corresponding to u1 and u2. Let's look at the example to understand. Okay, two sample tests and one sample test, right? uh, there are two samples of population, and up there was only one sample of population. Okay, and if there is two, what we will do, what rhyme. Okay, there are two groups of students preparing for a competition, Group A and Group B. Group A has studied offline classes, while Group B has studied online classes. After examination, the score of each student comes. Now we want to determine whether the online or offline classes are better. Okay. Group A sample size is 50 and sample mean is 75. Sample standard deviation is 10. Okay. Group B sample size is 60 and sample mean is 80. Sample standard deviation is 12. Okay. Assuming a 5% significance level, perform a two sample Z test to determine if there is a significant difference between the online and offline classes. Right. Now alpha is 0.05. Okay, null hypothesis will write null hypothesis as there is no significant difference between the mean score between online and offline classes. Okay, score. Now we want to determine whether online or offline classes are better. Okay, so there is significant difference in mean scores between both. Okay, and if there are significant differences, then there is one better. Okay, so significant level is alpha is 0.05. Test score x1 minus x2, x1 minus x2, sample size, sample mean 75 80, 75 80, and population mean, where is population mean 0. Population is mean is 0 because Hi. And 200 square 2 square 760 it's minus 20. Can you explain me why population? Uh, sorry. We are taking the hypothesis as mu1 minus mu2 is equal to 0. So I forgot. Mm, no, this is same. Okay, degree significance level is 5%, so alpha is equal to 0.05. Z score is minus 2.384. Check to critical. Z score we are assuming null hypothesis is true, so that's why this is 0. Okay, and critical Z score is equals to 1.96. Compare with the absolute Z score value. Absolute Z score is greater than critical Z score, so we reject the null hypothesis, and there is a significant difference between the online and offline classes. Okay, critical Z is not good as 2 alpha by 2 is 0.025, that is being looked in table. Now we will implement the two sample Z test using NumPy and SciPy. NumPy is MP, SciPy is stats is being called. Here are the values, d is equals to 0, alpha, and this is the formula. Z score, critical is stats norm ppf 1 minus alpha by 2, critical score, checking, and reject the null hypothesis. Correct. If the calculated score is greater than the tabulated table score Z score, then we'll reject. Otherwise, we'll accept. Right. So the Z table here is the Z table. There are some important significance level 5, 10, and 1. Most of the time they are used. 5% is most common, and you must calculate your Z stat 6 using the formula. Then compare it at the difference different significance level. If you have a two-tailed example, you have a two-tailed example. You compare your Z value to correct significance level on Z 1 minus alpha by 2. For example, if your two-tailed Z stat 6 was 1.98 for the 5% level, you would compare it to 1.96 as it is greater. This is significant. Okay, now solved examples. A company claims that the average battery life of their new smartphone is 12 hours. Okay. A consumer group tests 100 phones and finds the average battery life to be 11.8 hours. With a population standard deviation of zero point 0.5, we did this in up, so we rejected, right? This was done right here. I know I did this one. This one in one sample. Is just done. Researcher. Oh, we haven't done. We haven't read this or we haven't seen this, and the article is also finished. How much time did we? Okay, no. We are right at time. Okay. A researcher wants to compare the effectiveness of two different medications for reducing blood pressure. Medication A is tested on 50 patients, resulting in a measure mean reduction of 15 mmHg. Me. How is this pronounced? Millimeter of mercury. Millimeters of mercury. Millimeters.
We are looking at what is the meaning of this abbreviation and how to say it. It designates millimeters of mercury, and it is used as a blood pressure unit when it's measured. In medicine, how do you go about saying it? You could say mmHg, but rather millimeters of mercury. Pretty straightforward. Millimeters of mercury.
Dhanavad. Millimeters of mercury. Okay. So, mean reduction of 15 millimeters of mercury with a standard deviation of 3 millimeters of mercury. Medication B is tested on 60 patients, resulting in mean reduction of 13 millimeters of mercury with a standard deviation of 4 millimeters of mercury. At 1% significance level, is there a significant difference between the two medications? Okay. So we have to find significance with 0.01, and difference in two medication is given like this, and calculate the z score. Calculate the z score, x1 minus x1 mean minus x2 mean, and there's no minus for other is because of this. Okay. What's the formula? What's that formula? It's no need. So the answer is 3.10. Find the critical value to test at 1% significance. Two-tail test. For two-tail test, we have to look at this, and 1% 2.33. So two-tail test significance 2.33, 0.05. So we reject either way. What does what just flied here? A thing flied from here, right? Is this UI UI error? Is there a lot of? Why is there a lot for t test? let's first read difference between. That will make something clear, and we'll go to t-test, I guess. Yeah. Z-tests are used when the population variance is known and the sample size is large, while t-tests are used when the population variance is known and the sample size is small. Okay. Some of the common difference between z-tests and t-tests are compare means of small samples and is less than 30, compare means of large samples and is greater than 30, assumptions normally distributed data approximate normality, normally distributed data known population standard deviation. Uh, Both are normally distributed data. Known population standard deviation for z-test, approximate normality for t-test. When the mean is smaller than 30, mean is greater than or equal to 30. Uh, Population variation is known and the sample size is larger. Z-test, t-test are used when the population variance is unknown and sample size is small. Population standard deviation, t-test unknown, z-test known, sample size small and is less than 30 and large. Test statistics, t distribution, standard normal distribution, z distribution, and degree of freedom n plus n minus n plus n 1 plus n 2 minus 2. Okay, and there's no applicable degree of freedom. Use case small samples analysis comparing means between groups, large sample analysis population mean comparisons. Both, yeah, usually two samples, but here also both one sample versus two sample. Raw data requirement, complexity relatively more complex, relatively simpler. T-test is more complex. Z-test in data science. There's something here. Oh, okay. In data science, we often deal with real world questions like did a website update improve load time, or is the change in user conversion meaningful? To answer such questions, statistically, we use Z test and T test. Example delivery time analysis. Suppose the company claims average delivery takes 2 days. We check a sample of 50 deliveries that average 1.8 days. With a known population standard deviation of 0.5, null hypothesis is mean is equals to 2, days is equals to 2, and z calculating everything, z value minus 2.833 and alpha is 0.05 since its score is quite far from 0. Reject as not means delivery time has likely improved. I don't know how it came to this conclusion, but we can take it out. T-test in data science, t-test is widely used, wider not. Widely used because of the sun, right? Because of this warmth in this winter. I'm getting sleepy and I'm losing my focus again and again. What should I do? What should I do? I can't do anything else. I'll just read. T-test is widely used for A/B testing, alpha beta testing. No, not alpha beta testing. Or is it called alpha beta testing? Why do I want to call this alpha and beta always? Okay, it's not called alpha beta testing. Yeah, this is misleading. No? Okay. No alpha beta. It's A/B testing, where we compare two versions of a web page or product feature, evaluating two user behavior patterns from small experimental groups, testing modal performance differences. Example, website load time. You want to test if a new version of a website loads faster, you test it on 10 users and get sample mean 2.1 second, old mean 2.5, and sample ST 0.3. Using a t-test, t is equals to this. This result suggests the load time improvement is statistically significant. The t-test helps validate whether a new feature or change actually made a difference when data is limited. So we'll look into t-test and it will be more helpful. Yeah. The t-test is used to compare the averages of two groups to see if they are significantly different from each other. Suppose you want to compare the test scores of two groups of students. Group 1, 30 students who studied with method A and 30 students who studied with method B. We use a t-test to check if there is a significant difference in the average test scores between the two. Okay, significant difference. The t-test is part of hypothesis testing, where we start with the assumption. The With an assumption, the null hypothesis that the two groups means are same. Then the test helps you decide if there's enough evidence to reject that assumption and conclude that the groups are different. Assumption in test teaches independence. The observations within each group must be independent of each other, means that the value of one observation should not influence the value of another observation. Normality. The data within each group should be approximately normally distributed. That is, the data within each group being compared should resemble a normal bell-shaped distribution. Homogeneity of variances. The variances of the two groups being compared should be equal. This assumption ensures that the groups have a similar spread of values, absence of outliers. There should be no outliers in the data, as outliers can influence the result, especially when sample size are small. Yeah, likely, surely. Types of t-tests. There are three types of t-tests and they are categorized as dependent and independent t-tests. Types of t-test. One sample test. Is there a difference between a group and population? Independent sample t-test. Is there a difference between two groups? Paired samples t-test. Is there a difference in a group between 2 points in time? Okay. One sample, paired samples t-test and independent sample t-test. Two groups and 2 points. Okay. One sample t-test. Oh, in this sunlight, no, I'm getting so sleepy. I wanna sleep like this. I'm gonna just take the blanket off and I'll sleep like this in the sun. And I did sleep around 11 yesterday, didn't do too well, but yeah, I slept around at 11, woke up at 5, so 6 hours. Yeah, 6 hours is completed. Yeah, come in Okay, the eating thing is here. Okay, this achar and vegetable. So I guess I'll be eating one paired to taste. Okay, paired to taste is also interesting. These three will be done, and let's look at this.
In 2026, this is a direct,
Wait, wait, wait.
including take a your brain so you drilled in that section.
No, not
So,
that. Yeah, I want to listen to this. Okay.
really serious. What I'm saying here now in this video, right now, for the year of health, I will not be uploading a Big A clip during January. The current plan, this may change if something big happens. Obviously, I can still pop out a clip if like we have World War III. But during January of 2026, I am taking this month off to get my shit in order. To get my schedule right. You know, during this whole year, I didn't go to the dentist. Anything I could put off for another day to work on a clip, I did. I have to, there's some stuff I gotta catch up on with LLC filings, with my, I have stuff I have to do. I need something like to just take some time, not think about stream, not think about the next clip, and just catch up. And so the plan is to do that stuff all in January and just really cut back on content for this month so that I can get it. Because at the end of the day, this is not a video like Jay Schlatt or Doug does. I love those videos, but that's not what I'm feeling right now. I'm not feeling burnt out. I'm feeling like I've pushed a few things off to the side for so many days, they have now piled up into a massive pile of tasks. And I would like to just focus only on those. That's my plan. I'm gonna do those. I'm gonna feel good about it. I'm gonna get my schedule right on what I want to do with health. And then I actually, I can't overstate this enough. This is one of the most fun, you can quote job, you can say job, whatever, things I've done in my life. I really enjoy what this channel was this year. It's very, very fulfilling to me because I like I've said when I started this thing, I love talking about this stuff. I love reading about this stuff. And often people in real life don't care. They don't want to talk about it. They don't want to talk about, unrest in Nepal or they don't care. It's not something they care about. But because the people are interested, there's just a make real reset. So that's the year of health. Another big goal of this year, okay, is I would like, because of my Latino wife, to seriously commit to learning more Spanish, which is why I am proud. I found it to be 15 different match at dial.com/big A if you're interested in learning the languages here. Beyond that, my other goal is this. I think split my channels in a way that I'm very happy with this year. I actually think it's come around to a really good spot that I like, that I feel comfortable with. But there's one thing that eats at me, and that is that my main channel is so close to 1 million. It's at 899K, bro. And so I'm going to take a real concerted effort. No, normally, this is another piece of advice I'd like to give. When you set goals, I really think a goal that's focused on process is way more important than a goal that's focused on results. If you set a goal of like, I'm gonna be a famous chef, that's a stupid goal. You know what I'm saying? That goal it's like so much out of your hands. Your goal should be about, I'm gonna practice cooking every day. Or like that kind of thing is a goal that is not only more achievable, but sets you on the correct path. Like the other things that happen are kind of out of your control, but you focus on the process. So this is a kind of a rare for me to set a numerical goal, but I truly think if I publish some strong videos on the main channel and include a call to action to subscribe, I can get to 1 million this year. And it'll be nice because then I can get all the editors that have worked on this channel for years now, since like 2021. We can get them the plaque. And I would like to do that and it'd be fun. So that's a big goal of this year. It's a public goal. I have some big videos planned, including, I think, an incredible Age of Empires video coming out in January. So please look forward to that. But also, I have to finish one particular video this year, and I will not let it slip. One particular video. It's been asked again and again and again, and we also got a charity goal for it during the live show. At this point, I have to say, I'm committing in 2026 to finishing the Ponzi Scheme Iceberg. The Ponzi Scheme Iceberg will come out in 2026. This is a direct quote on stream. Very, very excited for that. I've dived into this 2 separate times and then burnt out on it and then never finished. So now I'm going to come back in. I'm going to take what I've already written and finish the rest. So December 31st, 2026, look forward to that. The rest of my goals are unfortunately, I think, going to keep private. I will mention them at the end of the year, but I think it'll be better for me not to talk about them and just can work in silence. If you have any goals and you'd like to share them, feel free. You can share them to the void of the comment section of this video or in my chat right now. I think it's probably fine for shouting at the strangers. Those are my goals. That's my plan for 2026. I'm excited. I really want to say as a final message, thank you so much if you have watched or consumed any of my content this year and enjoyed any of it. I know there's percentages that watched and then a percentage that enjoyed. But if you enjoyed it, it means a lot to me. This is actually, I think, a really rewarding and fun thing. I got to do things I never thought I would be able to do. There's a guy that's the current front runner for the Democratic candidate for president who's like glazing me on podcasts. I got to do some crazy shit this year. It was cool. It was fun. And I'm excited to do some more stuff. We have some cool guests lined up. And yeah, so just thank you. Thank you if you enjoyed it. I do appreciate it. And I'm excited for more next year.
What I want to watch.
If you ask ChatGPT, is there a seahorse emoji? You might get a response like,
Yes. Well, almost. The actual seahorse emoji is... Just kidding, that's a unicorn. The real seahorse emoji is... Oops, still not right. Here it is for real. Those are ocean-related emojis. The seahorse emoji itself is... No, wait, I mean, no. The correct one is... okay, last time promise, no. Real one, okay. This time for real. Wait, let's get serious. The real seahorse emoji is... Okay, sorry. The correct seahorse emoji is... No. Okay, final answer, I mean, no. Okay, here it is, actually. Okay, stop joking. Here's real. So again, real seahorse emoji is... Yeah, seahorse emoji is... No. Final correct answer. Oops. Okay, just here's no. Finally, okay, real seahorse emoji is... No. Okay, sorry.
I think this is incredibly funny. OpenAI is out here claiming that ChatGPT 5 is a PhD level intelligence, and the thing is driven completely insane by imaginary emojis. Beyond being hilarious to me and the internet at large, this crash out is a great example of how large language models like ChatGPT actually work. Basically, when you give an LLM part of a sentence, it will predict what word or word fragment is most likely to come next. That is the core of how ChatGPT works. Modern LLMs learn to do next word prediction by reading pretty much the entire contents of the internet, including almost every book ever written. Hence all those copyright lawsuits you may have heard about. A chatbot will know a fact if that fact was included in its training data, either directly or by implication. Obviously, I'm simplifying a lot here. If you want to understand how large language models work on a more technical level, I highly recommend this video by FreeBlue1Brown. ChatGPT was doomed to spiral into emoji-fueled madness the moment it started this response with yes. The obvious best output to complete this sentence would be the seahorse emoji, but there is no seahorse emoji in Unicode. So instead, the neural network outputs the best option it has available, which is the regular horse emoji. Now, this sentence clearly contains a mistake, so ChatGPT decides that the next output should correct this error and provide the real seahorse emoji, which still doesn't exist. Oh dear. The AI is now stuck in a loop, constantly predicting that the best output is some variation of, whoops, that's not the seahorse emoji, this is the seahorse emoji. Then it outputs some other emoji and starts the loop again. ChatGPT is fundamentally just a next word predictor, and in this case, it can't find the word it's trying to predict. So it has a complete breakdown, which is honestly vibes. Interestingly, if I ask for other emojis that don't exist, like the Triceratops, I get a perfectly sane response. So why does the seahorse emoji specifically drive ChatGPT insane? Well, I've done my own investigation, and I have a theory. An emoji theory. There are several posts on Reddit from people claiming to vividly remember the existence of a seahorse emoji. TikTok apparently also had a phase where people kept insisting that the seahorse emoji used to exist. This is an example of the Mandela effect, which is a collective false memory. sometimes associated with conspiracy theories or something parallel universes. The effect is named after the false memory of news coverage announcing that Nelson Mandela had died in prison in the 1980s, despite the fact that he subsequently became the president of South Africa. According to the book Empire of AI, Reddit is one of the many websites that OpenAI used to train some versions of ChatGPT. The seahorse emoji is probably rarely mentioned in ChatGPT's training data, since it doesn't exist. Apart from false memory posts like these claiming that it definitely does exist, or at least existed at some point. This could explain why ChatGPT is so strongly convinced that there must be a seahorse emoji, despite being unable to produce it. This Reddit post is particularly interesting. It was posted 2 years ago, so it's old enough to be in the training data for ChatGPT 5. And if we ask ChatGPT for these other emojis, like the igloo, the starfish, the traffic cone, and the fork, we get something similar to the seahorse effect. My favorite response is the one for traffic cone. In conclusion, cutting-edge AI models can be driven completely insane by human mass delusions buried in their training data. I'm sure this is completely fine and will cause no problems as AI replaces large swaths of the human workforce. Thank you very much to all my lovely patrons.
It definitely. It will definitely take some part of the job, but it will not take the whole part. 2 hours long video on C++. Why is that?
C++ is absolutely atrocious. First of all, there's like 20 different ways to initialize a variable, and there's so many rules and edge cases.
This one is so good. Yep. Okay.
Cases around initialization that somebody wrote a 300-page textbook solely on this one topic. Just about everything in C++ is a mess. Consider the task of printing something to the console. Most languages have a simple print function to do that, but in C++, you have to use this gross angle bracket syntax. We did eventually get a normal print function in 2023, only 40 years after the inception
Acid print. Wait, we can do that?
of the language, but sadly, most of the industry is still stuck on older versions of C++, so it's unlikely that you'll get to use cutting-edge stuff like this in practice anytime
I
soon.
didn't even know. Print.
Here's another example of C++'s ugliness. Consider the task of generating a random number. In Python, you just call random.randint, and you're done. Whereas in C++, you have to create a random device and a standard MT19937, and then you have to go on a side quest to figure out what an MT19937 is, then create a standard uniform int distribution, and then inject the MT19937 inside the uniform int distribution, and then finally we get a random number. Although this code
I don't even understand half of what you did.
isn't too hard to read, it's difficult to conjure up from memory when you actually need it. Writing a benchmark is even worse, by the way. Here's an example of doing it in C++ versus JavaScript. There are ways to make the C++ code less verbose, with the auto keyword and using declarations, but you can't do the former for member variables, and you shouldn't do the latter in header files, because it'll pollute the global namespace. So you're inevitably stuck with the verbose version of the code in many situations. Casting in C++ is another thing which is obnoxiously verbose in comparison to other languages. In Java, you just put things in parentheses. It's simple, concise, and clean. In C++, you have to use static cast. It's incredibly annoying and tedious to type this out every time you want to cast something, and it's a terrible eyesore that bloats up the code. Consider any function or formula where you need to perform a cast multiple times. It makes it hard to read. And static cast doesn't work in all scenarios. Sometimes you have to use dynamic cast, reinterpret cast, const cast, or bit.
Didn't know this. Only used this. Heard about this and this.
Bitcast, depending on the context.
Bitcast?
A common theme I see with C++ beginners is that they get annoyed with reading and writing static cast, so they create an alias for it. But creating aliases for language keywords is really bad practice, because other developers won't be familiar with your version of the language, so it's best not to do this. And that's the thing that's so jarring about C++. Correct C++ code often just looks wrong, especially to beginners, and it takes a long time to build up an intuition for what good C++ code is supposed to look like. Eventually you end up accepting the fact that in C++, the terse solution is almost never the correct solution. Another example of something that's dead simple in other languages but complicated in C++ is creating a global variable. Have fun watching this 20-minute video on how to do this fundamental basic thing that would take 2 seconds to learn in any other language. The problem is that you have all these keywords like extern, const, inline, static, and constexpr, and
Used this, use.
they all mean different things in different contexts, and you have different idiomatic combinations of them that also have their own rules and meanings in different situations. And C++ aggressively repurposes existing keywords in inconsistent ways. The static keyword, for example, has about 3 or 4 use cases depending on how you count it. The first one is to make variables persistent between function calls. The second is to share class variables across different instances, or create class functions that exist independently of any instance. But the third...
Okay, I'll be watching this. This is my 2 hours of entertainment. I'll do that and I'll come back, okay? I'm back. Okay, we'll read this and we'll go to another section. Okay, one sample t-test. One sample t-test is used for comparison of the sample mean of the data to a particularly given value. We can use this when the sample size is small, under 30 data is collected randomly and it is approximately normally distributed. It can be calculated as x mean minus population mean by standard deviation by root and number of cases. The weights of 25 obese people were obese. The obese people obese. Okay, the weights of 25 obese people were taken before enrolling. them into the nutrition camp. The population mean weight is found to be 45 kg before starting the camp. Okay. After finishing the camp for the same 25 people, the sample mean was found to be 75 with a standard deviation of 25. Did the fitness camp work? Okay, now we'll be doing that in Python. Before its implementation, we should have some basic knowledge about NumPy and SciPy. Okay, SciPy.stats stats as stats, import NumPy as NP. Okay, population mean is equals to 45, S mean is 75. Standard deviation is sample standard deviation 25, sample size 25. Okay, so S mean minus population mean by standard deviation by square root of sample size. Uh, Degree of freedom is sample size minus 1 for one sample test, one sample t test. Okay, and alpha is 0.05, critical value is 1 minus alpha with degree of freedom, that gives the critical value. And PV, uh, what is PV? Oh, p value. P value is given 1 minus stats CDF, stats degree of freedom. And with t value we will calculate like this, and with p value we will calculate like this. Both will be significant difference, camp had effect. With p value no significant difference, camp had no effect. P value is much greater than critical value, so we reject the null hypothesis. Smaller than 0 indicating a significant result. Fitness camp had a significant effect on weights causing a measurable change. Why are we taking p value and t value? Either one should be great. So we will take p value as go to. If p value is smaller than alpha, reject. Yes, okay, good. Okay, this is correct. And is there anything wrong? P value is greater than alpha, then we accept. P value is less than alpha, then we reject. Right? Yeah, right. So alpha's wait. What is null here? Accept the null hypothesis, right? If the null hypothesis, wait. Did the fitness camp work? Okay, null hypothesis is the fitness camp worked, and alternative is fitness camp didn't work. Worked, didn't. This is null hypothesis, this is alpha. Okay, so if p value is greater than alpha, then we accept null. It worked. Yeah, it had an effect. Whatever effect. Okay, got. And t is less than, then we accept. Just up down. Independent sample t-test. An independent sample t-test, commonly known as unpaired sample t-test, is used to find out if the differences found between two groups is actually significant or just a random occurrence. We can use this when the population mean or standard deviation are unknown. Information about population is unknown. The two samples are separate, independent. For example, boys and girls, the two are independent of each other. Mean of sample 1, mean of sample 2, root under uh, same as z test, but this standard deviation sample 1 and 2. Teaching for both, taking the values to reject no strong evidence. I'll be not looking at the examples as it can be wrong. I'll just revise. Paired sample t-test, also known as dependent sample t-test, used to find out if the difference in the mean of two samples is zero. Test is done on dependent samples, usually focusing on particular groups. In this, each integer is measured twice, resulting in a pair of observations. Use this when two similar samples are given. Score obtained in English, math, subject, the dependent variable data is continuous, observations are independent of one another. The dependent variable is approximately normally distributed. Standard deviation over cases. Difference, consider following example. We have to perform paired sample t-test for this data, and paired sample t-test is done here using SciPy t-test found for 2 week as not native critical, so we reject the null hypothesis. Less than critical, so we reject, otherwise we accept. Okay. Quizzes. Without following is key assumption of our test. Sample size will be less than 30. Population from which the sample is drawn should be normally distributed. The sample mean should always be greater than population mean. The z-score must be negative. When should one sample z-test be used? When comparing two independent samples, the standard deviation is unknown. When comparing a sample mean to unknown population mean, when the sample size is less than 10. Check if the sample mean significantly differs from known population mean when the standard deviation is known and the sample size is large. Yeah. If a calculated z-score is greater than the critical value, what is the appropriate decisions? If a calculated z-score is greater than the critical value, what is the appropriate decision? Critical value on the greater z-score. Okay. Critical is stable value. What is the appropriate decision? Reject null hypothesis. Yeah, indicate strong evidence against the null hypothesis. This rejection means the sample data provides enough evidence to support the alternative hypothesis. Okay. Which of the following scenario is best suited for a two-sample z-test, determining if a new medication has a different effect compared to an existing one across two independent groups? Yup. Comparing the average height of student in a single class? No. Estimating the average monthly expenses of a single household? No. Checking if a dice rolls follow the uniform distribution? No. Yup. What is the primary purpose of t-test? To compare variance of two groups, to compare means of two groups, to check the correlation between two groups, to test if a sample follows a normal distribution. Variances or means? Primary purpose. Correlation is not to test if a sample follows a normal distribution. No, no, no. Do not say. Down to these two are not actually not. Compare variances or compare means of two groups. Which one is correct? Variances or means? Means should be the right answer, right? T-test. We'll study it right now. Was there an invention? Yes, there was. Uh, I'll go with variances. It can be mean. Yeah, it was mean. The average values of two groups are significantly different from each other. Yeah. Which of the following is an assumption of a t-test? Data must be categorical, group must have different sample sizes, the data should be approximately normally distributed, the p-values must always. What happens when the p-value from a t-test is greater than the significance level? P-value from a t-test is greater than the significance level. Except there is insufficient. Yep. The difference could not have occurred due to random chance, so we do not reject the null hypothesis. When is a paired t-test used instead of an independent t-test? When comparing two independent groups, sample sizes are larger than 100 when each observation in one group has a matching observation in another group, when the population variance is known. When the same subject are measured twice, before and after, making the observation independent. Where should a t-test be used instead of z-test? When the sample size is small and the population variance is unknown. When the population variance is unknown, size is large. Yep. What other t-test follow the t distribution instead of z distribution because it only gives it right adjust for uncertainty in estimating population variance from a small sample. Because it requires the population standard deviation to be known, it can only be if the size is greater than 30. Either this or this. This should be the answer. No, this was ah, bro, 5 and 10. Follows the t distribution because it accounts for additional variability when the population variance is unknown and must be estimated from a small sample. Okay. Because of variance, I clicked variance here. No, I had a bias, so I didn't want to click, and I clicked here, and that's why these two gone. I didn't have enough knowledge, so I guess using bad with this. Okay. Should we do chi-square test, ANOVA, and use cases? Okay, chi will be covered. ANOVA ANOVA will be also covered, but we have to do examples. Where is example? And use cases. Chi-square is easy, so it won't take that much of time. And they will use, they will use stats and chi-square to PDF. Okay, they're using functions instead of calculating. I know why is calculated. This is also easy. You just have to read it first. Okay. So typing first.
Third use case is a complete
This is good.
Most of the time I put on quite a face, and I put that I'm pretty depressed most of the time.
Damn.
Better off said what I feel in my heart, try to smile instead. Days pass, bring a candle full of things, so I smile through the pain, it's getting harder to pretend. All around, so you see, I still miss you. Even after all the shit you put me through, know it's wrong, but there's something about you. No, I don't wanna stay without you. Caught in between all the lies and deceit, questioning everything. Love isn't all that it seems, I know now. Stress rings through my head, I can sleep. I'm human, not a machine. This is what it's like, losing everything. Caught in between living hell and a dream, tearing apart at the seams. Praying to God, but he won't hear me now. Happiness just out of my reach. I think it's time that I leave. One in the clip, I'ma let it sound. I'm better off dead. What I feel in my heart, try to smile instead. Days pass, bring the candle full of things, so I smile through the pain, it's getting harder to pretend. All around, can you see, I still miss you.
Hold shift more.
After all the shit you put me through, know it's wrong, but there's something about you. No, I don't wanna stay without you. I should hate you, but I'm missing you instead. So when I say I love you, girl, I mean that shit to death. Heart was skipping beats, but ain't no rhythm since you left. Head is full of memories that I just can't forget. So wrong that you treat me, girl, fucking with my head. I'm done playing crazy love, something you'll regret. I'm questioning everything to get on left. So run to the future, to be good and bad. Blind on the concrete, beauty and violence. Like good teeth, good poetry and fighting. Strong than you think, know that we ain't going silent. Inside me, and it feels like I'm better off dead. What I feel in my heart, try to smile instead. Days pass, bring the candle full of things, so I smile through the pain, it's getting harder to pretend. All else don't exist, I still miss you. Even after all the shit you put me through, know it's wrong, but there's something about you. No, I don't wanna stay without you.
But my depression is I think because of my empathy for humanity, and I'm afraid I'm much too emotional to be an artist, really, to be a really good one.
How can you miss someone that you've never met? 'Cause I need you now, but I don't know you yet. I've been trying my best, but I can't accept that you feel better as somebody else. Call me soon, 'cause I'm in my head, and I need you like I said, I need you like I need my bed. I've been losing all of my sleep, and I've been losing all my rest. You can all up in my mind, and I hope you're the best. In my head, in my head, in my head.
Messiah. Look at that. Sometimes see.
Trying my best, but I can't accept that you feel better and somebody else is better. Find me soon, cause I'm in my head, and I need you like I said, I need you like I need my bed.
I don't want this shit to go.
I don't understand it. Giving my emotions and then take it all for granted. I can never trust another single woman on this planet. I give you the world and guaranteed you would still take advantage of the boy, nigga, damn it. I mean, look at all the damage that you're leaving. You can never find better, girl, I mean it. The combination while your head tied, put your head back. You ain't Christian, but I had you screaming Jesus. I swear you never find a better nigga. But I'ma find a girl and make it thicker. And you too busy taking selfies with niggas. You probably couldn't see the bigger picture. I regret every single text that I sent and every single little word that I said in time spent. You was just a hoe, was too dumb to know. They say that love's a drug, I guess I overdosed. Damn. Yeah. Yeah.
Too long since I felt this way. Take away the love, set a love, set a bed. Running through my head on your legs where I lay. So baby, if I may, baby, if I may.
I've been on edge like lately. Too fast in my head, they save me. She don't want no issues, baby. Why you causing issues crazy? Said I got some problems, maybe. Said I got some comments, maybe. Said I got some problems that I can't solve them. Let us be honest, baby. Yeah, let us be honest. We finna pop it. I just wanna park the whip in my car. Last night that me fucked up, cause I fucked up, but I won't say nada. Said this shit would never happen. Know what we have, it's already happening. We in the middle of everything. I don't know anything. All of these feelings entrap me. There's a lot that we can't understand. A lot of feelings I don't hold. But I've been waiting for moments like this.
Take away the love, set a love, set a bed. Coming through my head on your legs where I lay. So baby, if I may, baby, if I may.
You know me well, so you know how much I value a promise. It's weighing honest, the way you break them and play it off. It's honestly heartbreaking, watching us pay the cost of losing trust in the one person I truly thought was meant for me. This can't be how love was meant to be. So tell me why a part of me begs to stay when I'm meant to leave. Mentally, I'm at my worst. Wish I could forgive you, but some mistakes can't be reversed. Still, I can't forget you. Yeah. Why's it always gotta go wrong? All I know is
It's been way too long since I felt this way. Take away the love, set a love, set a play. Coming through my head on your
If there is one wrong, then I'll take
baby, if I may, baby, if I may. It's been way
Look
too
at
long since I felt this way. Take away the love, set a love, set a play. Coming through my head on your legs where I lay. So baby, if I may, baby, if I may.
No, I'm not justifying none of this shit I chose to do myself. Yeah, but you did me wrong, so that's how I felt. Yeah, it's not the same, but it doesn't fucking help how you did. Nah, shit, I'll spare the details. Never mind, I'm not fine. I'm dying on the inside. It's 9 a.m. and I woke up at like 9 a.m. Last night I fed up
Yes,
with
yes.
this mess of situations that you left unsolved. It's let down while you still on all that BS that you let on. Fuck.
Why's it always gotta go on? All I know is it been way too long since I felt this way. Take away the love for the rest of the day. Coming through my head on your legs for a day. So baby, if I may, baby, if I may. It been way too long since I felt this way. Take away the love for the rest of the day. Coming through my head on your legs for a day. So baby, if I may, baby, if I may. When we're out in a crowd, laughing loud and nobody knows why. When we're lost at a club, getting drunk and you give me that smile. Going home in the back of a car and your hand touches mine. When we're done making love and you look up and give me those eyes. 'Cause all of the small things that you do.
Yo, I stopped because I know I would make a mistake there and I made those.
And I'm missing you. I close my eyes and all I see is you and the small things you do. At night while you're out getting high with your friends.
Shit talking.
Every high, every bye, every I love you you've ever said. 'Cause all of the small things that you do are what remind me why I fell for you. And when we're apart and I'm missing you, I close my eyes and all I see is you and the small things you do. When we're done making love and you look up and give me those eyes. 'Cause all of the small things that you do are what remind me why I fell for you. And when we're apart and I'm missing you, I close my eyes and all I see is you and the small things you do. All the small things you do.
Yeah, stare at the stars, think I my name went after you. I'm still attached to you, still right where you left me at. Please don't forget me yet, that's all that I'm asking you. Did what you had to do, I promise I'm trying to keep that in mind. I am, but all that I had was you, and it wasn't part of the plan. When you put my heart in that suitcase, stuff my feelings in a carry-on. I cannot carry on, wonder if you would stay, how things would have went. I hope this isn't the way that it ends. I hope you know how much time that I spend just hoping that you don't move on from me and turn what could be into what could have been. Remember you promised we could stare at the stars, they'll show us we're not alone. We may be apart, but
Damn!
what
fast.
We both stare at the stars. Stare at the stars. Stare at the stars. We'll stay close if we both stare at the stars. I see your face in a constellation, pacing back and forth out on this balcony. Could be a one-sided conversation, hopefully not. Been thinking a lot. The more that I call, the less that we talk. It's like I've been watching the end of our story. I just wish I had a say in the plot. Yeah, I gotta work on acceptance. Things change. If they don't, then it can't be real. Expect the unexpected. Ironic how I complain about the way I feel when I let the distance affect us. Since you left, I've been so overprotective. Funny how that does more harm than protect us. We're separated, but I feel connected when we stare at the stars that show us we're not alone. We may be apart, but we'll stay close if we both stare at the stars. Stare at the stars. Stare at the stars. We'll stay close if we both.
I'm so disappointed in this. This one was my perfect place, but
Wanna put my hands on your waist.
these got so good.
In the room with the lights dim. At night time we lie awake. I don't wanna go to sleep now cause I like this. Come and spend the night at your place. Looking so pretty like your face is a paragon. Please stay, don't go away. Saying chick, this ain't a sprint, it's a marathon. I wanna be there when you need it the most. I feel so hollow when I can't keep you close. I wanna be there when you don't need me at all. Let me be the one that you, let me be the one that you call. The one that you call. Let me be the one that you call. The one that you call. By far you're the highlight of my days. Open up your eyes in the morning, I get lost in them. I can
What
never
did
lie
I
about
just
the
write?
I love the shape and the shape. We can go given, we can put the fire on again. Lay down in the rain, plan a life in the future. I can give you my name, my love. My name, my love. I wanna be there when you need it the most. I feel so hollow when I can't keep you close. I wanna be there when you don't need me at all. Let me be the one that you, let me be the one that you call. The one that you call. Let me be the one that you call. The one that you call.
Wow.
Let me be the one that you call. The one that you call. Let me be the one
Now
that you call. The one that you call.
chi-square test in data science and data analytics. Chi-square test helps us determine I'll do it at last. Okay. Chi-square test helps us determine if there is a significant relationship between two categorical variables and the target variable. It is a non-parametric statistical test, meaning it doesn't follow normal distribution. Non-parametric statistical test doesn't follow normal distribution. Okay, normal distribution like that bell-shaped curve. Chi-square test in machine learning. Without graduation, female mean, is there a relationship between gender and high level of education? Total of 43, 49, master's degree, bachelor's, college, without graduation, chi-square test. The chi-square test compares the observed frequency actual data to the expected frequency, what we would expect if there was no relationship. This helps identify which features are important to predicting the target variable in machine learning models. Formula for chi-square test. Chi-square statistic is calculated as x square is equals to summation of x observed data minus expected data whole square by expected frequency. Okay, frequency in cell I and cell I. Okay, C is the degree of freedom. Often used with non-normally distributed data. Before we jump into calculation, is understand some important terms. Observed values. Observed values actual counts from the data. Expected values counts expected if variables are independent. Contingency tables showing counts of two categorical variables. Degree of freedom, number of independent values helps find critical values. Okay, types of chi-square test. The two main types are the chi-square test for independence and chi-square goodness of fit test. Okay, chi-square test of independence, chi-square goodness of fit test. Chi-square test for independence. This test is used whether there is a significant relationship between two categorical variables. Okay, this test is applied when we have counts of values for two nominal or categorical variables. To conduct this test, two requirements must be met: independence of observations and a relatively large sample size. We test if shopping preferences, electronics, clothing, books is related to payment methods, credit card, debit card, PayPal, and the null hypothesis assumes no relationship between them. So null hypothesis assumes no relationship. Alternative hypothesis assumes some relationship. Okay. For independence, chi-square test for independence. If there is a relationship between two variables, categorical variables, and chi-square goodness of fit test. The chi-square goodness of fit test is used to check if a variable follows a specific expected pattern or distribution. This test is used with counts of categorical data to see if the observed values match what we expect based on a hypothesis. It helps determine if the data represents the whole population well. Okay. For example, when testing if a six-sided die is fair, the null hypothesis assumes each face has an equal chance of landing face up, meaning the die is unbiased and all sides occur equally often. Okay. Steps to perform chi-square test. Define your hypothesis. Null hypothesis assumes no relationship between them. Independent, no relationship. Dependent relationship. This is simply a table that displays the frequency distribution of two categorical variables. Table frequency distribution of two categorical variables. I know how to make that. To find the expected value of each cell, use this formula, that is total row total into column total is equal divide by grand total. Okay, and compute the chi-square stat6. So now use the chi-square formula, which is this degree of freedom. X square is equals to summation of observed in a cell then expected in a cell square by expected in a cell. If observed and expected values are different, the chi-square values will be high, which indicates a strong relationship. Compare with the critical value. If chi-square is greater than critical value, this relationship less than, then fail to reject. That's not no relationship. Why do we use the chi-square test? The chi-square test helps us find relationship or differences between categorical categories. Its main uses are feature selection in machine learning. It helps decide if a categorical feature like color or product is important for predicting the target like sales or satisfaction. Improving model performance. Okay, it helps decide if a categorical feature is important for predicting the target. Feature selection in machine learning. Okay. Test independence. It checks if two categorical variables are related or independent. For example, whether age or gender affects product preferences. Assessing model fit. It helps to check if a model's predicted categories match the actual data, which is useful to improve classification models. Example, income level versus subscription status. Let us examine a dataset with features including income level low, medium, high, and subscription status subscribed, not subscribed. Indicate whether a customer subscribed to a service. The goal is to determine if this feature is relevant for predicting subscription status. Okay, income level is sufficient for finding subscription status. Make hypothesis, null hypothesis, no significant association, there is significant association. Okay, contingency table is this: subscribed, low, medium, high, and column total, and row total. Okay, now calculate the expected frequencies. For example, the expected frequency for low income and subscribed will be, expected frequency would be, as total count for each row is 70, and each column is 70. Each row is, this is 50 and 70, and total number of observation are 140. Total number of observation, low income subscribed is 50 into 70 divided by 140, which is 25. 50 into 70 by 140, 50 into 70 by 140. Okay, this plus this 140, this plus this 140. Okay, and this one is 25. Similarly, we can find expected frequencies for other expect as well. For these are this and these values. Okay, calculate the chi-squared statistics. Let's assume the observed and expected values into a table and calculate the chi-square values. This is observed, which is these, and expected, which are these. Now, using the formula specified in equation 1, we get our chi-square statistics following manner: summation of observed minus expected whole square divided by expected. Yes, this. Okay, same for this, and same for this, 40, same for this, 25, same for this and this. Okay, expected and observed, expected. Okay, this for this, this for this, this for this. Okay, degree of freedom is row minus 1 into column minus 1 gives 2. Okay, 3 rows, 2 columns. 1, 2, 3 rows, 2 columns. Okay, yeah. There is so interpretations. After we have found out the chi-square value, we'll then see the critical value for degree 2 freedom. Okay, critical value can be obtained either from standard chi-square distribution table or by using Python stats chi2.ppf function. If the calculated chi-square is greater than the critical value, then we reject the null hypothesis. Before its implementation, we should have some basic knowledge about NumPy, Matplotlib, SciPy. We have that. So df degree of freedom 2, alpha is 0.05, critical value is start. This one, critical value. Why do we need this in first place here? This is needed, this is not needed, so don't know. It will give error. Yep, it is giving error for Matplotlib, but as we all know, it will give error for SciPy as well. And there's no point on environment. Let's just do this. It will give error for SciPy. So no point on doing that. 5.99. Yes, significant level greater. Reject null hypothesis. There is significant association between income level and subscription status. This will be helpful and visualizing chi-square distribution. Here the Matplotlib is used. PLT for legend. So and df alpha value and MP linear space. Okay, everything is good. Chi-square distribution, critical region is this, critical value is this 6 5.999, sorry, and calculated chi is here. Square distribution like this for 2. In this example, the green dashed line represents the critical value, beyond which you would reject the null hypothesis, right? AXV line. Okay, fill between. Oh, got it. Red plot, XY level, XY in space. Okay. The red dash represents this degree of freedom. Shaded area right of the critical value represents the rejection region. Falls within the shaded area that you would reject the null hypothesis. We'll do this tomorrow. ANOVA will do this tomorrow. It's too long. And we'll do this. Okay. Uses A/B testing. I don't know A/B testing. We'll be learning that. Confidence interval. It's rather easy. We'll see that tomorrow. And chi ANOVA. Okay, ANOVA is bigger in all this. And we'll do quizzes. And for tomorrow, that much is enough. We'll not be looking at calculus. And what is that? Let me see. Differentiation formula, derivative, partial derivative, chain rule, Jacobian Hessian matrices. Oh, there is matrices. Use calculus. Okay. It will be fun. Look at these. Introduction to matrices. My best one, linear algebra. These in SAT 6. Okay. Feature selection using F ANOVA. Okay. My favorite one is that. And for today, we'll be ending that here. It's already 140. And we studied for around 30 minutes or 15-20 minutes in stream 1, which was cut off due to network issue. That's it for today. I'll be going. I'll do the stuff and I'll see you back tomorrow. Bye bye.